looking at Glencoe Course 2 Math, Lesson 5.4 on the distributive property. Now, the distributive property does a couple things. First of all, when something is in the form where we would distribute, we have numbers written very simply. Okay, it's a very simplified form of a set of numbers. We can expand that set of numbers when we simplify using the distributive property. And if we write out what that distributive property means, it expands even further. So, what I want to look at first is what distribute means. So if there's a distributive property, the distributive property says that we're going to take a number outside of a set of parentheses, and we're going to multiply it by anything and everything inside the set of parentheses. Okay? So, think about it this way. If I was going to distribute your quiz to you like I am on Monday, I take one thing and I give it to everybody in a group, correct? Mm-hmm. Okay. Parentheses group things. That's what's going on. That's what's happening. Okay? So, we're taking a number or a term that's outside a set of parentheses, and we're going to multiply it by everything that's inside. Let's look at what that actually looks like. If I look at example 2, example 2 says 4 times the quantity x plus 7. That means that I have 4 sets of x plus 7. Now, yesterday we learned about the associative property, and the associative property said that I could regroup things. Okay? I'm going to combine the associative and the commutative properties together for just a second. So I'm going to rearrange my numbers using the commutative property and regroup using the associative property so that all my x's are together and all my 7's are together. Okay? So do I still have 4 x's? Mm-hmm. Do I still have 4 7's?
Yes.
Okay. I can combine and I can say instead of this that I have 4 x's. And instead of this, I can say that, well, 7 plus 7 is 14, plus 7 is 21, plus 7 is 28. So I can rewrite 4 times the quantity x plus 7, which is in a form that we would distribute, and I can rewrite that as 4x plus 28. I don't want to have to do all of that, though. Because that's a lot of work.
Yeah, that gets me really confused.
Okay?
Yeah, because you're just really repeating it.
Right, we just keep repeating ourselves. So instead, this is what I'm going to do. I'm going to show that I'm going to take that 4 times the quantity x plus 7. Same thing, right? Mm-hmm. Okay. But I'm going to distribute the 4 to my x, and I'm going to distribute the 4 to my 7. So I have 4 times x plus 4 times 7. 4 times x we rewrite as 4x. 4 times 7 is 28. Did we get the same thing both times?
Yes, ma'am.
Yeah, we got the same thing both times. But the second way, using the distributive property, so this second way, when we use the distributive property, It's a lot easier. Okay? By a raise of hands, who would rather do it this way?
Me.
Okay? This way shows what allows us to do this. Okay? This justifies what the distributive property says. So this was example 2 with justification. Do we have any questions? No?
No.
Fantastic. Let's look at a couple other examples where our variables are in a kind of different spot, or if, let's say we have a negative somewhere. Let's say that we're not adding. Let's look at some examples to see what we need to do. So I'm looking at page 377. The next thing that I'm going to look at is example 4. Example 4. That says that I have negative 2 times the quantity x minus 8. What is different about this example compared to this one? What's different about those two examples? Let's raise a hand. What's different between them? Yes, ma'am.
The 2 is negative.
So we have a negative 2 this time. Yes.
And there's a negative 8.
But I thought that said subtract 8.
Oh, my bad.
Is there a difference?
Yes.
Is there a difference?
Yes.
Yes, ma'am. No.
Yes.
If I... Hold on. When we were adding integers, we KCA'd things so that we found the additive inverse of that second term. If I KCA this, I keep my x, I change my subtraction to addition, and that 8 becomes negative. So is it really different? No. No. We do want to KCA though when we solve problems and their subtraction within our parentheses, because that will help us to make sure that our negatives are appropriately accounted for. Alright? So we had a subtraction sign. We realized that that really means that our 8 is negative. Okay? We start with a negative 2. That negative gets distributed with the 2. So I'm going to take all of negative 2, multiply it by x, and all of negative 2, and multiply it by negative 8. So I have negative 2 times x, and I'm going to add to that negative 2 times negative 8. How do I handle a negative 2 times x? What do I do with that? How can I rewrite that into a simpler form? Because I don't like having my multiplication symbols in there. Yes, ma'am.
Negative 2x.
Negative 2x. Keep our plus sign. What's negative 2 times negative 8? Don't forget your integer rules.
16.
16. Thank you. Next time, raise a hand, please. Negative 2x plus 16. That's it.
That's all?
That's it.
You sure?
So what's the answer?
Negative 2x plus 16.
Whoa.
That's all there is. There isn't any more to solving these problems.
That was easy.
Now, let me rephrase. Right now, that's all there is. Okay? We might have this thrown in the middle of another expression. we might have this on one side of an equal sign and we need to solve for our variable when we get to solving equations. But for right now, in this particular lesson, on this particular day, that's it. Can I combine x's and numbers?
Yes.
Can I?
Yes.
Can I combine ice cream cones and numbers?
No.
What if those represented tires? Can I combine tires and numbers?
Yes.
No? I can combine tires and numbers?
No.
Zeros. Whoa. I think.
See, my 0 looks more like this, and I don't think we want a tire that looks like that.
That's
Right.
A 0 don't look like that.
Zero is circle.
Okay.
A 0 is this.
I think we're in one of those moods where you're trying to disagree with me just to disagree. Yeah, right? Okay. These are called different terms. Numbers are one type of term. Each variable represents a different type of term. If the terms are different, you can't combine them. Okay? So you can only combine numbers with numbers. You can only combine x's with x's and y's with y's and w's with w's. Okay? You can't combine t's with q's. You can't combine r's with x's. It doesn't work. Okay? Now, when I talk about combine, we're talking about adding. When we finalize that simplification. We are going to look at an example where we have a couple different variables, and let's look at what happens there. Okay? If we look at example 5. Example 5. Hey, let's use blue again. Can someone please read example 5 for me? Hands up. If you'd like to share, yes, sir. We'll come back to you. Yes.
5 in parentheses negative 3x plus 7y.
All right. 5 times the quantity, negative 3x plus 7y. Close quantity. When I distribute this, I'm going to distribute my 5 to the negative 3x and to the 7y. Remember, when we have a number in front of a variable, that number is called a coefficient. We can work with coefficients.
We can.
We can. Our variables, though, are just going to kind of get tagged along for the ride. All right? At this point, our variables are just along for the ride. So, 5 times negative 3x plus 5 times 7y. What is 5 times negative 3? Negative 15. Who's along for the ride with negative 15? X. Alright? X is along for the ride. We're going to add to that, what's 5 times 7?
35.
35. Who's along for the ride with 35? Y. Alright? There are situations where our variable's not just along for the ride. And that's if we were... Okay. We can distribute a variable. We can distribute a variable to other variables. We can distribute variables to like variables. And then we can deal with exponents. Okay? For right now, this is where we stop. Can I combine X's and Y's?
No.
No. Can I combine ice cream cones and tires?
No.
ma'am.
No, there's no such thing as an ice cream cone tire.
Yeah. You can make it. No, like the tire could be like edible.
Okay.
It could be
So-
a tire ice cream
You
cake.
can make a round cone and then put like syrup all over it and then put sprinkles and then put some ice cream.
All right. Again, you're trying to make things work that don't. I love the creativity. Creativity belongs in a whole lot of places. Math is not that place.
Oh,
Okay?
yeah, you gotta have math.
To make problems.
So, we're going to finish up real quick. Stay with me for just another minute. The point of this part of the distributive property says that we're going to multiply our term directly outside of our parentheses by everything inside, and then we're going to simplify. All right, and then we're going to simplify. There is a way that we can undo the distributive property. That's called factoring. We'll get to that later. Okay? All right, before we close, are there any questions?
No, ma'am.
Fantastic.